Hello, I hope you're having an awesome day, and I hope you're ready for some more excellent information about chemistry. Today, we're going to be talking a little bit more about the periodic table. We're going to talk about the different groups in the periodic table, the different columns, and we're also going to talk about the different sections of the periodic table and what some of those different elements are like. Okay, so I think you're going to enjoy today's lecture as we go through this information. All right, so let's see if I can get you going here. There we go. These are the families of our elements, right? And so we want to locate and describe the properties of alkaline metals, alkaline earth metals, transition metals. And we're going to tell you a few more too. The properties of halogens and noble gases, and relate the element's chemical properties to the electron arrangements of its atoms. Again, tying it back into how the atoms' electrons are helping to form its properties. So first one that we're going to talk about is the alkaline metals. Now, the alkaline metals are the first column, group 1. They all have a 1+ charge when they form an ion because they have one valence electron. They are not found in nature as pure elements because they're so reactive. They want to get rid of that electron so much, okay? But they will be combined with other elements to form compounds. For instance, sodium, table salt. It's going to be a perfect example. Sodium is a soft metal. Most of these are going to be kind of soft metals that you can be able to basically cut with a knife. And it's kind of cool if you want to look up, alkaline metals in water on YouTube. You're going to be able to find some interesting explosions. All right, these things will actually explode in water, some of them, especially as you get to cesium. At the end of this video, if you watch that video, you're going to see cesium basically shatter a bowl, which is kind of cool just by putting it in water. So the alkaline metals are very, very reactive. Now the next one is the alkaline earth metals. Now that's group 2, so they are forming a 2+ charge when they form an ion because they have 2 valence electrons, and they are still reactive. They're not as reactive. One of the reasons they're not as reactive is because once they've given away one electron, then they're going to have a slightly positive charge, and so they're not going to want to give away the next electron as much. But they still do react pretty strongly and are forming mostly compounds. Rarely, but sometimes you will find them in nature in their elemental form. Okay, seashells, magnesium compounds, milk of magnesia, which is a drink for your stomach. Excuse me. Strontium, an element that you'll find in flares. Okay, and so these are pretty cool. You can see that barium, which is right here, that's used in looking at your intestines, right? So look at your colon. You'll have to drink some barium, and then they'll shine an X-ray on you. And because barium is such a dense nucleus, right, and it's a dense metal basically, then your intestines are going to show up, and details will show up in your intestines, and they can see if you have some problems in there. Anyway, that's the alkaline earth metals. Another reason that they come from, as far as the name earth, alkali, comes from some original Arabic. Okay, if you look up the origin of those words, and then the earth part is that it's not actually something that will burn. So you think about bones. If you stick some bones in the fire, what kind of substance you're going to get out. So it had to do with the fact that it wasn't able to burn the way that other things like the alkaline metals were able to burn. All right, so anyway, the transition metals, these are the ones that are all in the middle. Okay, this one's right here are the transition metals. The bottom one are the intertransition metals, which we're going to talk about here in just a second. But these guys are the transition metals. And what you want to see here is that these are all very similar in properties, but they will slightly change as you go across the periodic table. They're not very reactive. And so you're going to find these things in nature a lot of times. For instance, gold, silver, copper, right? These things you can imagine that you find mines of copper and gold and silver, right? And so these things are found in nature. Why do we use things like gold for jewelry and as well as connectors in computers? Well, because it's easy to bend and shape into the shapes you want, and it's very shiny, very reflective, and does not corrode. Okay, and then that's tarnish, that's another word there for that, and it also is highly electrically conductive, and so that's why we use it in computers so well. Very good conductor of electricity. Metals. Now these intertransition metals, like I said, are the ones that are right here, Okay, and they're actually in group, they're in period 6 and 7, but this is actually part of the 4th energy level and part of the 5th energy level in terms of where their electrons actually fit. But on the period, we would say, oh, you insert those guys right there. I know that's kind of a little bit confusing, but that's kind of the way it is. You'll learn more about why that is in chemistry. A couple examples, uranium and plutonium. These guys are radioactive, and many of them are man-made. Okay, so if you look at the periodic table in the classroom, you can see that some of the elements have kind of like a clear outline. So they're kind of clear on the inside and they have an outlined shape. Those are the man-made elements, the ones that we don't find in nature anywhere, but they're just discovered. And for instance, plutonium is one of those. Okay, another one is americium, which we find in smoke detectors. Okay, so then let's go ahead and jump across the periodic table. Let's talk about our noble gases. Right side, column 18, group 18, family 18, and you'll notice that these guys have 8 valence electrons, okay, except for helium. Helium only has 2 valence electrons because it only has 1 energy level. That's all it can actually hold. It's just 2 electrons, okay? But the others have 8 valence electrons. And remember, they have this full octet. They are satisfied. They don't want to react. The name noble gas is actually originally derived from the guy who coined the term. It was Edelgas, which is in German. It was rare gas. And so these are inert gases or rare gases. Now, inert gases is actually kind of a misnomer now because we actually have been able to form compounds with a lot of these. But for the most part, these guys do not want to react, and they're going to be by themselves in nature. And it's also kind of a misnomer to say that they're rare gases now, because we now know that argon is one of the principal extra gases in that 1% of our atmosphere that is other gases. So interesting anyway. They don't really react, like I said. They have the outermost energy level of their electrons filled. Helium is an example, okay? We have that in balloons, neon signs, argons and light bulbs, and lots of other different uses, but noble gases, or Edelgas, as originally were called. Now, sometimes it's interesting to think about the fact that nobility, right, doesn't want to deal with the peasants. And so it's easy to remember if you think about, the noble gases are noble. They don't want to deal with the peasants, and they don't react with them or interact with them. So if you want to think about it that way, you can, but not necessarily how that word originally came about. Halogens, group 17, okay? These guys all have 1 valence electron that they want. So they have 7 total valence electrons, but they want 1 more to get that full octet. And so they're going to be very reactive. These are the most reactive of our nonmetals. Okay, you're going to see we're going to use chlorine compounds to kill bacteria, right, in swimming pools. It's going to be part of our salt, right, sodium chloride. We can use fluorine compounds for our teeth. When we brush our teeth, we got some sodium fluoride that we're putting on there to try to prevent tooth decay. We use iodine in the medical field to disinfect wounds and to also improve our thyroid function. So we've got lots of cool uses for the halogens. Then we have other nonmetals. We got just a few that are right up in this little column here. And these guys are used very, very commonly. Carbon is probably the most ubiquitous of these, right? We find carbon in everything. Organic compounds are compounds that have carbon in them. And you and I are made up of carbon, right? Lots and lots of carbon inside of our bodies, as well as things like the graphite and pencil and the diamonds that we have are all made of carbon. Okay, other things that we find in nature, all of these guys. You're going to see lots of, especially these right here, the fertilizers that we give to different types of plants are going to have various amounts of these types of compounds or these types of elements in them to make them successful. All right, and also oxygen and nitrogen, most common elements in the atmosphere, right? The atmosphere is made up of 1% oxygen, 78% nitrogen, 1% argon, and other gases. All right, then we have our synthetic elements. Again, these are the man-made elements, the ones that I said on this periodic table in the class have just kind of like the outline. And there are a lot of them. Okay, the very first one that we discovered, well, actually, I'm not sure which one the first one was that we discovered, but this is the one that is the furthest up in the periodic table. It's element number 43, and so it's actually pretty early on the periodic table, and there's a while before you see any other radioactive or any other synthetic elements. But this is one that is currently used to diagnose and treat cancer. We also have things like promethium, which is used in glow-in-the-dark paints, and americium, like I said, used in household smoke detectors. basically everything bigger than 92 is also going to be synthetic. Okay, 92 is uranium. So uranium is natural, but after that, they're all synthetic. Okay, so yeah, so we got this little technetium 99 being used to help with the brain scan. So that kind of covers what we're talking about here today with our family's of elements. We can now, right, tell you a little bit more about the alkaline metals, the alkaline metals, alkaline earth metals, where they are at the periodic table, and the transition metals, right? We know where those are. We even know where the intertransition metals are. And we can locate and describe the properties of halogens, noble gases, the far right side. Group 17, group 18, right? One more electron it wants, and it doesn't want any electrons, right? So because it wants one more, most reactive. Because it doesn't want any, it's the least reactive. And then we can talk about that electron arrangement, right? That's exactly what we're talking about. Most reactive most reactive elements are going to be the ones that have one or, well, let's just say one electron to either give away or to take, okay? That's the alkali metals want to give away its one electron, and the halogens want to take its one electron. And so it's very common to have an alkali metal combined with an halogen, so that way those two can interact with each other and form new compounds. All right, well, that's all I've got for you today. I hope you enjoyed learning a little bit more about these elements and how they are, used in our world. You get onto YouTube and watch that little video, you're going to probably get sucked in like I did. I just went in, and I've seen that video like a gazillion times, but I just went in to watch it again, and then I got sucked into all sorts of cool sciencey videos, and that's probably going to happen to you. So be careful. Beware of the time suck of YouTube. You're going to learn a lot of really cool things. But yeah, you might need to get work done before you get sucked in. So have a good day, guys. God bless you.